Now, 33.6. In questions 1 to 6, find the first four terms. Show that the difference between the difference is constant. So, I have to find out T1, T2, T3, T4. It's done exactly like last time. So I'll do question 5 as an example. Is everybody ready? So, anywhere I see an N, I put in 1. Anywhere I see N, I put in 2. And then anywhere I see N, I put in 3. Anywhere I see N, I put in 4. Is everybody with me at the moment? No. Okay, somebody say no. Now, we get here, guys. Is this 1 squared plus, put into the calculator, okay? So, like, we're not, well, I'll just do it in my head here. 4 minus 2 is 2. The next one, 4 plus 6 minus 2 is 8. 9 plus 9 is 18. That's 16. Next one should be 16 plus 12 is 28. 28 minus 2, 26. Now, is this a linear sequence? Does it go up by the same amount each time? No. So the first difference is 6, 8, and 10. That's the first difference. Now, the difference between the differences, do you see that word there? Differences between the differences is the second difference. What's the difference here? 2. Doesn't change. Now, make a prediction. What do you think the next one's going to go up by? 12, which will turn this one into 38. The next one's going to go up by 14, which means the next number along will be 52. Do you get the trend? Alright, I'll press pause. Okay, let's find the first four terms. That means find T1, T2, T3, and T4. I've done that. And show that the differences between the difference is constant. What constant means is show that it's a regular number. So see the way the difference, what is the difference between the differences? The answer is 2. 2 is a constant, therefore you just have to do your answer. Is that okay? The differences between the differences is just the same number over and over again. The differences are linear because the first difference is 6, the second difference is 8, and the third difference is 10. That's a linear sequence. But the differences of the difference is just the number 2 all the way down. So it stays the same. It's constant. Okay? Okay. I'll do another one, okay? We'll get another. We'll do another one, okay? Another one's a good idea. I'll do number 4. N squared plus 4. Does that make sense? 1 squared plus 4, 2 squared plus 4, 3 squared plus 4. Everybody pay attention. 4 squared plus 4. We got 5, 8, 13, and 20. Now, these are that's T1 is 5, T2 is 8, T3 is 13, T4 is 20. Yes? Now, the difference is 3 for the first two, 5 for the second two, and 7 for the third two. The difference of that is the difference between the differences. Okay? The black numbers here are the differences, and the difference between them again is the number 2, and that's all we need to know. The difference between the differences. Okay? Then you go to another type of question, like this. Continue the diagram to find the next 3 terms in the sequence. T1 is minus 1. T2 is 0. So look at this. Okay? A gap of 1. The difference goes from 1 to 4. What's the next one along? 7 and 10. What this reads is this. To go from minus 1 to 1, you go up 1. To go up 4, you go from 0 to 4. And then 4 plus 7. And then 11 plus 10. 21. So, that's T3, T4, T5. The first difference is 1, 4, 7, and 10. The difference between the differences are 3, 3, and 3. Okay, finally, rocket ship. Now, a rocket is launched and its path, this is question 10, and its path is described by the following formula, where h is the height of the rocket in meters, and t is the time in seconds after blast off. Find the height of the rocket after 1 second, 2 seconds, 6 seconds, right? So, if I do this as a series, guys, h, I can do it like this. T is equal to 10t minus 10 minus t squared, okay? Now, imagine this. What happens if I want t1? What do I do? 10 times 1 minus, which is 9. What happens if I want t2? Yeah. Okay. Which is 16. T3, which is, what'd you say? 24. 21. Interesting one, this one. Okay, next one. T4, which is 24. And then T5, 10 times 5 minus 5 squared equals, and then finally T6, yeah, 24. Now guys, look at this. Does it tell me to draw a graph? Okay. Show the path of the rocket on a graph, okay? Now, T1 means the distance you travelled after 1 second. T2, 2 seconds. And T6, how high were you after? 6 seconds, okay? So, we put that together and we just bring it over here for seconds. Now, so question 2, is this a linear sequence? It is not a linear sequence because the first difference is not the same, is it? First difference is not the same. Therefore, this is not a linear sequence. Everybody happy with that? If it's a linear sequence, it goes up by the same amount each time. It doesn't. Okay, so we can get rid of that. Now, no, because it doesn't go up by the same amount each time. Show the path of the rocket on a graph, putting t on the horizontal axis. Okay. Now, we're going to draw this graph here. Just being a bit lazy with it. That's why we have squares there. So what we're going to do is we're going to make a graph. Now we have to go as high as 25, don't we? So we start at the very top, work our way down. Let's see if we have 25 blocks or not. We'll find out very soon. Let's count up in fives. 5, 10, 15, 20, and 25. So we have enough blocks there to draw it. Okay. How many seconds did we use? 1, 2, 3, 4, 5, and 6. Now what we're going to do, guys, is we're going to call this is time, isn't it? In seconds. How do we know that? The question says it that the formula here is where t is time and h is seconds. So what's happening, guys? After 1 second, if I was to draw these points here, what do these points actually mean? After 1 second, you're at a height of 9. After 2 seconds, after 3 seconds, you're at a height of 21. After 4 seconds, and after 5 seconds, and then 6 seconds, you're at 24. So what we want to do here is this. 1, 9, guys, is here. 2 what is here. Wait. Here. I always do that. Ugh. Okay. And then next one after that, 3, 24, 21. I'm on a roll now. Yeah. Next one. Yeah. And finally, 624. Look at this, guys. Ugh. Let's try this again. Steady hand. Ooh. Not too bad. Now, what is the maximum height the rocket reaches? If this axis is height and this axis is time, what is the maximum height it reaches? How do you know that? The peak of the graph, it hits it at 25, and how many seconds did that occur after? There, we'll go again with that one. 5 seconds, 25 meters tall. That makes sense? Okay. By finding the difference between the differences, confirm that the graph is quadratic. Quadratic graphs, lads. Quadratic graphs are curves. Do you understand? Does that make sense? Linear graphs are straight lines. Remember we drew the straight lines? Quadratic graphs, you know what I mean by quadratic? It has a t squared in it, or an x squared. These ones are, what's that word? They're curved. So how do you confirm that it's a quadratic graph? To confirm that it's a quadratic graph, what you do is this. The differences between the differences are going to be constant. So in all quadratic graphs, the graphs that are drawn like this or like this, the second difference is always the same. So that's 7. What's that? 5, 3, 1, and -1. And then the difference between them, it's going down by 2, isn't it? So -2 is a constant. The differences between the difference is constant, therefore it's a quadratic equation. Will everybody remember that, Joaquin? That the difference between the difference is constant when it's a quadratic sequence. We just confirmed it's quadratic because the difference between the differences is -2. It's constant. Can you tell if the rocket has reached its maximum height? The rocket has reached its maximum height because it's gone up at 25, and now it's on its way back down again. So yes, it has reached its maximum height. Okay, guys.